Alrighty, Ross, can you read the first objective?
Define and describe higher order functions.
Alex, can you read the next objective?
Write a function that takes a function as a parameter and calls it.
Wonderful. Jason, can you read the next objective?
Call a higher order function, passing it an anonymous function as a parameter.
Anonymous. Marlena, can you read this next one?
Call a higher order function, passing a named function as an argument.
Matt P., can you read this one?
Call a higher order function, passing it a reference to a function as an argument.
And Fahed, can you read this last one?
Identify this as a higher order function.
Yes. This is an interesting success criteria. There are a lot of things that are higher order functions. This is one that you would have seen yesterday in the events lesson that is a higher order function. So first, let's define and describe higher order functions. So there are two cases where a function is defined as a higher order function. The first case is a function that accepts a parameter that is a function. So can someone tell me what is a parameter to a function? Think like in your own words, what is a parameter to a function? Matt P.
It's a little thing that goes between,
Doesn't have to be little.
well, you know, whatever variable you're passing to the function could represent anything, but in this case.
So just to summarize, any variable or thing that you're passing to a function, and you said it could be anything, so it could be a number, it could a string, a boolean, and we're going to talk about it can also be a function. Okay, so when you call a function, you can actually pass a function into it and do something with that function. Okay, so that's the first type of higher order function. The second type of higher order function is a function that returns a function. So think in your own words, what does it mean for a function to return something? I'm going to cold call in 5 seconds. Cold calling means I'll call your name. Stephen, in your own words, what does it mean for a function to return something?
After a function completes it returns something to the whenever you call it.
Can you describe it without using the word return?
It gives you something.
Yeah, I like it. So a function that gives you something back. Like, yeah, and it's so hard to describe it without the return keyword. Fahed, do you have another one?
Yep. A function that can be assigned to a variable.
I know what you're talking about, but if you use those words, we actually could mean a variable that has a function inside of it. But what we care about is what is
The result.
Yeah, the result, and that's another word that's not return. The result of a function that ultimately we could assign to a variable or something like that. So you can invoke a function, you can get a value back. A higher order function can actually return another function. Like it literally returns a function, and then you can call that function somewhere else. So let's. So those are the two cases: a function that accepts a function as a parameter, or a function that returns a function. Everyone, think about it for 20 seconds. What is a higher order function? Also, try to put it in your own words, and maybe start to think about why would we ever want to do this. Oh, that's the answer. Don't do that. Okay, I'm going to cold call. Caroline, can you give me one case that makes something a higher order function?
Kind of like nested functions, so where you can input a function as the input to function.
Yes. Can you say the same thing without the word input?
You can pass in a function to a function. and
Yes.
use it within the function.
So the first case is a function that accepts a function as a parameter, so you can pass in a function to another function. And then what is the second case? Let's think about it. Michael, what is the second case for a higher order function?
Second case of a higher order function is a function which results in another function.
Yes, so a function that returns or results in another function. So those are the two cases. You can do a lot of different things with it. So the first thing we're going to talk about is a function that takes a function as a parameter and then invokes it. So let me get up just kind of like a little test bed set up here. So you'll commonly see Hoff, that's higher order function. earlier when Berto was like Googling it, he came across like Hasselhoff talking about higher order functions. And Hasselhoff was mentioned in stand-up this morning. But regardless, let's call some functions. Okay. So here I have a function. Let's call it what's that? Master function. Okay, let's be a little more precise because I was gonna say like do the thing, but let's be precise. Can someone think of something that takes a long time? It's not something that doesn't finish immediately. It can be anything in the world. Baking. I like it. Okay, so function bake the cake. Okay, so the idea is when we invoke this function, the cake is not immediately done, right? We have to wait for the cake to be done. So what we're going to do is we're going to pass in a function that bake the cake can call when the cake is done baking. This is a beautiful example. Okay, so I'll say bake the cake, but right here I can pass in a function. So I'm going to say a function. We'll talk about and kind of clarify, this is an anonymous function because I'm not putting a name on it. But right here, I'll just log the cake is done baking. Okay, everyone reach into the sky. So this is our first case for a higher order function. So bake the cake is a higher order function because it accepts a function as a parameter. So inside of bake the cake, let's say we have some long-running task like gather ingredients, then we mix in a bowl, then we preheat the oven, then we put the cake in the oven, and a whole bunch of other stuff, but this is going to take a very long time because baking cakes takes a long time. Question? No. Scratching head. Okay. So if let's just do this. So if I invoke this function right now as it is, and I try to store the result in this variable called result, what will result be? Everyone think about this for like 10 seconds. So just given the code as it is right now, what is result going to be? Any guesses? Any ideas? Let's see a hand raise. Jason? It won't. Any other guesses? Marlena? Undefined. So if you define a function that does not return a value, it implicitly returns undefined. So right now, that's really what our function is doing. We haven't actually done anything inside of it. So by simply invoking this function, and then if I log result, result is just going to be undefined. Let's clear this. Undefined. So the function is not returning anything. And that makes sense because baking a cake takes a really long time. We don't just immediately get a result out of it. We have to wait for that result to come back. So on this line here, I'm invoking bake the cake, and I'm passing in a function. So on line 1, when the function actually gets invoked, this word done is going to be equal to this function here, the function that I'm passing in. So given what you know about JavaScript, and I'm telling you right now done is a function, how can I make this actually console log the cake is done baking? Any guesses? Inside of this function, what can I do? Raise a hand. Caroline.
You would have to call the function that you, so like the function, it was inputted, so now it's not being run, it's just like an input, it's not going to run in the actual function.
So we're saying this is the input, now we need to actually run it. So if I then invoke done, I'm actually invoking this function that got passed in, right? So now, result still is going to be undefined because this thing literally doesn't return anything. But eventually, after all these things are done happening, done gets called. So now when we do this, the cake is done baking, and then we get the return value, right? So the idea of this being a higher order function is that we can pass in this function, and it gets called when it's done. So right now, I'm just going to remove result because it doesn't really make any sense because this function doesn't return anything. We can introduce set timeout. And set timeout itself accepts a function and a number of seconds to wait until invoking that function. So let's say we did this, where we call bake the cake accepts done, which is a function, and then we set a timeout. So in 3 seconds, that's when we'll actually bake the cake. So, and actually, let me just turn these into console logs, because that'll be fun. Okay, I think that's good enough. So we invoke the function bake the cake. These things get called, and then 3 seconds later, the cake is done baking. So all that stuff happened, and then the cake is done baking. So the idea is, like right now this is kind of contrived because I'm like manually setting this timeout. But in the real world, we're going to be doing things that don't complete immediately, like requesting data from a server. And so when that data comes back from the server, we can call a function and pass in the data to show when it's available. Go ahead, yeah?
Yeah, so the past function done, can I send parameter with that function?
Yeah, definitely. So let's do this. So instead of putting that there, let's pass in a message to this function. And then right here, we can say the cake is done baking.
So we don't need to define anything in the between the parentheses.
Exactly, because that is the value. This represents the function itself. Doesn't really know or care about like what parameters it actually takes in. Then when it reaches this line, the JavaScript engine knows, okay, when this function was defined, it accepts one parameter, so that's going to be passed in there.
Okay. And what if I need those parameters inside the function for like specific case?
That's a closure, and we'll talk about that at a later time. Yeah. So, but let's just see how this works. It's going to work in exactly the same way. Then ultimately, we're invoking that function and passing it a value. So bake the cake is a higher order function because it accepts a function as a parameter, and then at any point in time can invoke that function later on, right? What questions do you have about this? I see a lot of confused faces. Alex.
Is there like a framework you have in your mind that keeps it all straight, or is it just something you kind of like you work with enough to like understand it?
I think trying to understand every single line of code really helps. So on this line of code right here, I am invoking bake the cake function. So I see bake the cake, and then I see these two parentheses. So that means I'm invoking the function. Then anything that comes inside of an invocation are parameters that's being passed. So this tells me that this entire thing is a parameter that's going into the function. Then on this line up here, like I wrote the code so I know that this is a function, but I can compare this function with the function that was defined, saying that it accepts a variable called message. So when I invoke it here, the value is passed into there. I think what I'm trying to say is be very literal about every single line of code you're reading. Don't take anything for granted, right? Because we can kind of just like hand wave over this bake the cake function part right here, and like, oh yeah, there's just a function in there. But that is literally a variable. We're literally passing in the value, and then because it's a function, we can use parentheses to invoke it. Kind of embedded in your question there as well is, if there's a lot of this going on, it can get very messy. Like, you're passing functions into functions into functions. Who's calling what function? Yeah, like that can definitely cause confusion as to what's happening and why and where. That said, like really the nature of JavaScript itself is the fact that it is asynchronous, meaning we can wait for things to happen and then invoke functions when those things are done happening. That's really a roundabout way to say I've been doing this a long time. But at the same time, like, don't take anything for granted. Like, this is invoking a function and passing in a variable. This is invoking a function and passing in a variable, which happens to be a function. This is a function with no name that accepts a parameter message, that kind of thing. Caroline.
What's like the benefit of doing anonymous functions instead of like, is it just that you didn't have to define it?
Yeah, so that's a really great point, and let's look at our objectives. So write a function that takes a function as a parameter and calls it. I'm going to call that done. The main idea being we can pass a function in. So this other success criteria, call a higher order function, passing it an anonymous function as an argument. So there are different benefits to like whether or not we actually pass in a named function. This right here is an anonymous function. And the idea is we didn't have to predefine it, like we defined it in line there. So that is an anonymous function. I could, however, define the function out here and say like, call it like print message, something like that. And then now that this function has a name, instead of passing it in and defining it on the same line, I can just pass in the name itself. And that and compare this with the anonymous function version are exactly the same thing.
So you'd literally put that function minus print message where print message is.
Right there. Yes. And the idea is this is the name of a variable. That variable happens to be a function. And so kind of the exact same thing is happening. Instead of an anonymous function defined in line, we're actually getting the name of another function, but it happens in the same way.
Can we go back to the way you had it real quick?
Yeah, definitely. And I'll leave it up there. So
I'm curious where the function done comes in. Does done automatically assume the role of the anonymous function?
it does. And so the other way I want you to think about this is just like any other parameter, I can call this anything. It doesn't assume that name until the function actually gets called. And now if I call it anything, now I need to call it there. But the idea is it's just a parameter. Like the function is just another variable, and you can name the parameter anything and invoke it here. But just like with any other function, like the variable names that you pass in don't have to match the names of the arguments defined on the function. So even though here it's an anonymous function, let's throw that on there. Here it's a named function. No matter what I'm actually passing into bake the cake, up here I can call it anything, but it just represents the function itself. Will?
It's like in a method where you're using a anonymous function as a callback.
Mm-hmm.
I don't think I've seen it before where inside that larger method function you call it at the end. So if you put the anonymous function in line as a parameter, does it automatically call it?
It's I guess the question you're asking, and the answer is no. The function that you call, inside the code somewhere, it's going to be invoking that callback, whether it was an anonymous function or not. So right now I have this being invoked at the end. This could be invoked like at any time. The idea is it's a function, it's a callback function. I can call it at any time. So if I did that, the cake would be done baking before we add the ingredients, but still, this is a variable passed to the function. If I want it to be invoked, I have to invoke it, right? If I don't invoke that, we're never going to see the cake is done baking. So whatever function you're passing anonymous functions into, somewhere they have written code that will eventually invoke that function. Go ahead.
So with the named function, I can pass it to the bake the cake if it's named function.
What's that? Yes, here. Is that what you're asking?
Bake the cake, that's it. Okay, but I can't pass the parameter here. Okay.
Yes, so so in this case, we're invoking the function, passing it anonymous. In this case, we're defining a function and just passing in the name of the function.
Without parameters.
What's that?
Without the arguments.
Yeah, without
Oh, yes. And because we're passing the function itself, right? Because if we passed in, like if I did print the message and then passed in hello,
We'll call it.
well, it immediately calls it. The return value is undefined, and then it passes. So and that's the other thing about like being deliberate when you're reading code. So print message invoked with hello. What does this function return?
Hello.
Undefined.
Undefined, because there's no return statement. So when we resolve the expression, this becomes undefined, and then we're actually invoking bake the cake with undefined. So when it reaches this line, it's going to say, I can call this anything is not a function, because we're actually passing in undefined. So let's do this. So print message, the error. I can call this anything is not a function, because this first resolves to be undefined. And if you invoke it with undefined, then when it gets up to this line here, this is going to be undefined, so it doesn't know how to call that. So we pass it without the parameters because we want the value of the function itself. We don't want to invoke it. We want to wait for the function to invoke it when the time has come. All right. Think to yourselves for a second, what's the difference between passing an anonymous function into a higher order function versus passing a named function into a higher order function? What is the difference? Can I have a volunteer? Will.
In terms of like overall functionality, if you name a function, you can reuse it elsewhere, but in terms of within that individual function, nothing.
Yeah, like the end result is exactly the same. One of the benefits is we now could reuse this function. So let's say, and this is a pretty generic function, right? It accepts a message and then just logs it. So I could call this function anywhere. And by predefining it, now I don't have just like that anonymous function sitting there, because this right here is not reusable at all. Like I defined it once, and now the only person that could reuse it is Bake the Cake. But after this line of code executes, that function doesn't have a name. I can't call it in any way. So we have called a higher order function and passed it an anonymous function as an argument. We have called a higher order function and passed it a named argument as a function. Well, actually we didn't. We called a higher order function and passed it a reference. The other thing you could do is, just like the anonymous function version, I'll say passing a reference. This is passing a named function. So in line here, you could define a name on it. And that's almost exactly the same as passing an anonymous function, only in this case, it has a name. One place where this is very convenient is actually, let's do this. Let's say inside of here, I'm going to try to invoke undefined. Like this just should not work. It's broken code, right? So what we're going to see is in the stack trace, we'll actually see the word print message. And the stack trace is basically the log of all the errors that have happened. So let me actually comment out everything else. So we're going to invoke Bake the Cake with this named function. But then later on when that named function is called, we're going to get an error, and we'll see what the stack trace looks like. Undefined is not a function. But notice right here, it says at print message. So I know that line of code, the error happened in a function called print message. If I do this same thing with the anonymous function, and inside of here try to invoke undefined, in the stack trace, you'll just see this. You'll see there is no name of the function because it's anonymous. So it really is good practice to, like, instead of just using anonymous functions, put a name on the function so that way in your stack trace, you actually see where the error happened. Will?
Just like a general question about this, since you have something laid out, like a place where I found myself getting turned around once you start having lots of functions with nesting is like how a parameter, like if you're going to pass in a value to a function and then another function takes that as a function, like do you have any like advice for just like tracing like how that's moving through? Like if you put in something that's being processed by a function and that's being processed by a function and so on, it can just get disorienting, like where the variable's coming from.
Sure. I would recommend just like diagramming it. Like you could even, what's that?
Let's whiteboard it.
Yeah, like literally whiteboard it. So you could say, and like actually draw arrows. It might end up looking like some sort of tree. Like this function receives this argument, calls this function, which passes that in as another function. Really, like it just might help visually to draw it out. And really there's no predefined way for kind of like drawing that. I think like whatever works for you, but you're kind of like tracing the code and drawing an image of like where each thing might happen. Like and on those lines, like I have been coding for so long that like I have like a stack trace in my brain. Like when I'm debugging code, I'm able to think back like 30 lines. Okay, this called this, which is using this, and like kind of like form that mental model. It takes practice, it really does. Like the more you look at code, the more you follow it, the more you try to figure out what's happening, the easier it is to follow what's getting called where. Diagramming is awesome. Also debugging. Let me see if I can attempt to invoke the debugger. Let's see what happens. Didn't work. And then it immediately exits. I'll figure out a way to do that, but the idea is you can invoke a debugger for Node and then use, actually I could just run this code in the browser. I'll do that. Starting up an HTTP server on my machine to view the page. But if I look at here, let's look at the app. Maybe is it debug? No. Either way, here's what I can do. I can go in here, I can click on sources, I can see app.js, and I can add what's called a breakpoint. And the idea is when the line of code reaches that, I can step through line by line and actually see what's happening and actually see the scope too. So right now I'm paused on this breakpoint. I can press this button to kind of like step into the next line of code. So right here, when I press next, it's actually going to jump up to the top because I'm invoking bake the cake. So I'll do next. Now I'm inside of this function. You can also look at like the call stack. So this is each function that has been called. Let's do that. You can also see the scope table. So this is every variable available inside of this function right now. So right now there's that and that. I can see like the console log happen, that happens, that happens. We reached this line of code. Because this is a function that was passed in, when I press next, it's actually going to jump down to that line of code where I defined the function. Boom, we're down here. This actually gets invoked. Message is equal to the cake is done baking. I can then go to the next line of code, which is the end of the function, and then the code is done running. So pull your code into the browser, open up sources, and then just set a breakpoint somewhere. The idea of a breakpoint is when the line of code reaches there, all execution halts, and it allows you to kind of like step line by line and really see what the code is doing. So this also helps a lot to see like, okay, this function called that function. This passed that value, that kind of thing.
So you didn't have to put in the debugger line in the program for the sources to work in the browser. That's just something else.
No, like that actually did work. So, but I think that's the key. The dev tools have to be open. This debugger keyword is key. So if you know there's one line of code where something is happening, put that keyword there, and then when you open it in the browser, when that line of code gets reached, everything will just immediately stop, and you can open up the dev tools and like kind of inspect everything.
There's a package that lets you put breakpoints in to your app code.
What's it called?
It is called Node Debugger.
Okay. But like similarly, like basically you click a line and what it's going to do is like literally insert the debugger keyword. And the idea is like once that line of code is reached, all execution will halt. So let's do that. So if I refresh the code here, hard refresh. So now it halts inside of this function because that's where I put the debugger message. This is a bit of an aside, not exactly a trap because it is pretty interesting, but the objective we were working on is call a higher order function, passing it a named function as an argument. And really, we're seeing the difference there. So when you pass in a named one, if there are any other errors, you're actually going to see that name printed in the error list. If you just pass an anonymous function, you don't see the name of it. You just see, oh, some error happened somewhere. OK. Let's look at that Learn article, see if they have any other words of wisdom, maybe some better examples. Yeah, and so this other type of higher order function that actually returns a function as a value. Let's do something interesting. I think I'm just going to. Let's see if you can figure this out. So let's create a function called add that accepts a value. and then this returns a function. So add is going to return a function that accepts another value. And this function is going to return value plus another value. Just stir on that for a second. Okay. So when I say var, let's just call it result for now, equals add and then pass in 3, what am I getting back? What is the return of that function, and what is now inside of result? We're going to think about it for like 20 seconds. Any ideas? Maybe somebody I haven't heard from yet. So what is result?
Function.
Will, so you're saying function? Why do you say that? You're not wrong. I just want you to say it.
It's equal to a function with the number 3.
So, if we think about, like, okay, I'm invoking a function here. Regardless of what happens, I'm going to get the return value of that function stored in this value here, right? Add returns a function. So result is actually equal to that function right there, right? Okay, so if result is a function, what can I do with it? What do we do with functions? Jason? Yeah, so like we could invoke it. Like literally, because this function returns a function, now I could invoke it. And let's say I'll say var new result equals result with the value 4. So when I log new result, what am I going to get? So kind of just think what happens there. So we already decided that result is going to be equal to this function, right? You're getting back a function. Now, we're invoking result here on line 4 and storing that in new result. So what does result return, and what is inside of that variable? Well, first, let's just say this. So what does this function return? This function. Well, I mean, not even like. Yeah, so like the addition of 2 numbers. That is what this function returns. So Jacob mentioned it's 3 plus another value. So if we look at this line, and we know that result is the function which was returned with the value of 3 inside of it, when this line executes, value is going to be 3. And then another value is going to be 4. So what is new result? 7. Because we know how to add, maybe not because we understand this, but the result is 7. Will?
Is that like JavaScript just looking for like, okay, we've given it these 2 things and it needs 2 things, so we're gonna put this, like it can't be that, so how
No, it's like literally read the code. So this is a function, it returns a function. So if this just returned like the value itself, what would you say is inside of result? 3, because we're getting the return of the function. So it behaves in exactly the same way, but now instead of just values, like you're literally getting back a function, right? So you can't think of it like it's just like magic is happening and it's just assuming. There are no assumptions being made. Like every line of code is intentional. Like, Marlena?
So I think maybe because I was kind of like lost as to how another value was picking up the 4. And I think it's the return, that first return is important, is that it literally puts the function another value in result. And when it returns that.
Well, so this line, this result right here is actually just this function. It's not the result of the function.
I guess
yeah.
I don't know, maybe I'm misunderstanding.
No, go for it.
But basically, the way that I'm envisioning it is that 3 is passed as value, and then it literally returns, like, if it were to print out something, it would print out, like, the function.
Yes.
And then new result calls that and puts 4 in the another value spot.
Mhm.
And that's why another value is able to pick up the 4.
Yes, you have a perfect understanding of this. So, what should we actually call result? Like, what are we getting back? What is result?
That function with another value.
Okay, but we invoked it with 3, so what is result now?
It is 3 plus.
3 plus
a number.
3 plus anything. So this is literally a function called add3. And now we have this totally reusable function, add3, where we can just pass anything into it, and we automatically get that number plus 3. So this is going to be result, and then here, when we log the result, we'll get 7. This is a lot to swallow, especially like, there's a lot going on here. But Caroline, yeah?
I guess my biggest trip up is how does what we're now calling add3 have access to value? Because that's the one part, like I get.
Yeah, so this comes to Fahed's question, like this is a closure. The idea that even after this function returned the value, this function still has access to that because the outer function has closed over the inner function, so it still has access to that scope even though it disappears.
So it's almost like, I know it doesn't do this, but it's almost like you could add a line in the inner function of saying like temporarily stamping like value equals 3 or something. Like once value is invoked.
And that's a good way to think about it, like a temporary stamp. Like the return of this function keeps the value that was passed into it. In this case, the value was 3. So we could do this all day long. We could say like var add 20 equals add invoked with 20. And now we have a reusable function that will add 20 to anything that's passed in. Will?
Alright, so like, sorry I'm alone and this is a trap, then ignore it.
No, go for it.
You said, you want a diagram that's if you're having trouble wrapping your head around how things are actually passing through. Like, could you give us an example?
I could try, yeah. And actually, let me run this through the debugger too, so we can see what's really happening here.
Yeah, step by step.
And
Are you going to Slack out this code later?
absolutely, and it's recording, so. I will say this is like the hardest part of JavaScript, and like also we're at this point we're kind of doing functional programming. The idea of like accepting functions, invoking functions. This here is also called currying because like we're holding on to values. Like this is intense stuff. So if you don't get it right now, that is totally fine. Okay, so the line of code has stopped right here. So if we look at our scope, there are no variables defined. So if I go in here. It should be in global. Yeah, that's tricky because it is add3 actually is in the global scope because it's there. That's fine. Actually, let's just do this real quick. Let's wrap everything in a function called run examples. And so by doing this, I'm creating a brand new scope for everything else that's inside of it. And then here I will run examples. So, cool. Now we have a nice little local scope with all of our values. So right now, the code ran, so all those variables are undefined. Kind of like hoisting happened, right? All these variables are defined there. So here we can go in, and we're going to be defining add3, which is currently undefined, as the result or the return value of invoking add3 and passing in 3. So when we invoke add3, we're going to jump up to line 35. So right now, add just got invoked. And the value is 3, right? We're passing in the value 3. And you'll see value 3 there. But now, we are returning this function and storing that in add3. So now, you'll notice add3 itself is a function. It was the return value of invoking add. And then we can log that function out. Now, result is undefined. We're going to now invoke add3 with the value 4. So watch what happens. When I go into this next line, we're going to jump to line 36, but you'll notice that this closure thing pops up. And so that's that hidden scope that got captured earlier on. So if we look at the closure, the value is equal to 3, because that was the value from when it was invoked before. And now another value is 4, so we return 3 plus 4. And so now result has the value 7. So what was the comment you made, Caroline?
It's almost like reverse of the scope of, otherwise, like if you think about like generally when you know scope of like a variable is available in the function but not outside of it, it's like the opposite.
And it's because this is returning a brand new function. So like the way the internals of JavaScript work, like if we want this to work, like if we want this to have access to the value, this idea of a closure is introduced. Like instead of the scope table just totally going away, it holds on to it so that way the next time the function is called, it can access those variables. So now result is 7. Wonderful. We can do the same thing with add 20. So we go in, we pass in the value 20. That actually creates this closure and passes back the function. Now we have add 20. And then when we invoke add 20, the closure in this case, the value is 20, because that's what it was the first time that we invoked it. So now 20 plus 100 is 120.
So is that closure then specific to the variable where you find it? So you make variable at 3, so now that value is always 3 only when you basically recall that function?
Exactly. And it's mainly because like we assigned the return value. So the return of this function has a closure inside of it because we passed a value into it. And then the return of this function has a new closure inside of it because we passed another value. Just like anytime you invoke a function, you're going to get a brand new scope. In this case, we're getting a brand new closure each time because it's holding on to those values. This is a lot. I think the main takeaways, functions can accept functions as parameters, and they can invoke those functions. Functions can also return functions as a value, which results in like a thing like a closure. What is one higher order function you have seen in your JavaScript programming life? Matt?
Map?
Yeah, totally. Let's look at it. So if we down here say we have an array. It has the values 1, 2, and 3. And we say dot map. Map accepts a function that will be invoked on every value in the array. So we'll have a function here, value. And if we read the docs on map, we'll see that the function should return the new value for every value in the array. So let's say we want to double the values in this array. I could return value times 2. And then I'll say var doubles equals that. If we log it out, we should get the values 2, 4, and 6. But map itself is a higher order function because it accepts a function as parameter. And the idea is that right here we're just defining the function. We are not invoking it. When we call map, map will figure out when and how and why or whatever to actually invoke that function. This is just the definition. Map eventually will invoke the function.
I didn't understand this syntax for the doubles equal.
Oh.
I mean the 1, 2, 3 dot map.
Oh, you don't understand that? Or oh yeah. So it's literally I'm using literal syntax instead of storing it in an array. So let's call this numbers. Numbers. Set that equal to that. It's just like that.
Forget the question.
No, it's totally fine. Yeah. And again, I kind of want to go back to just like evaluate every line of code because what I had there was the ultimate expression, which was the array. But when we're looking at this, that could be a variable. It could be a variable or be the array itself.
Dot to string is. It's just like dot to string. I mean, dot to string.
What about it?
It's just like it. That's what I'm saying. The numbers dot map. It's like.
It is a property on the array. Yes. Yeah, and because the idea is the array, the built-in array has lots of different things. So yeah, it has map, it has filter. So I could say var evens equals numbers dot filter, function that accepts a value, and this should return is the value divided by 2 equal to 0, and this will give me all even numbers inside of that array. Can anyone think of another higher order function that you've come across?
Reduce is the one that always throws me.
Yeah, but it's very similar to like map, filter. It is a function that operates on an array that gets passed in a function.
For each?
Yeah, for each is another one, yeah. Any other ideas? What about in relation to the DOM? Add event listener, yeah. So I mean, that was the success criteria I got rid of, but if I right here say document.add event listener, pass in, well, let's say we want to listen for the click event, pass in a function, that alerts you clicked me. Or how about reach into this? Hey, stop it. So add event listener is a higher order function. So notice it accepts more than one parameter, but one of those parameters is a function that will get called at a later time, like when the click event happens. So now when we're over here, skip over that. Hey, stop it. Hey, stop it. Hey, stop it. Cool. Yes, this is higher order functions. If you got everything that I said, you should just leave this program now. But if not, work on it. Learn about functions. And I didn't mean that. Please don't leave. But this is going to take time and like a lot of like mental juggling and mental hoops until you like really get the hang of this. Cass, can you speak to now your mouth is full, but I'll give you time to chew. Speak to the idea of a higher order function, like the fact that you can pass functions into other functions. One, do you get it now?
It's still kind of mind-blowing.
Okay.
Okay.
And when you were introduced to it, any words of advice or?
Honestly, I just kind of like put the words in my brain and just like sat with it. And then eventually you'll start using them and start recognizing them, see what's going on, and then it'll start making sense. But
Yeah, and most of my examples here were like very contrived, like just very simple functions. When we start using actual libraries that are doing things, it's going to make a lot more sense why we need these things, like why we have higher order functions. All right, any last questions or comments? Chase.
Is there any resources that we can look at?
It's a great question. Absolutely, yeah. So in Learn, I'll Slack this out. Article on higher order functions. They have some other examples in here, even with like set timeout, set interval. They also talk about iterations, so like for each and map and reduce and stuff like that. So I'll Slack that out. We also have some exercises. I'll get you those as well. Let me see real quick. Actually,